Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k square minus 1 divided by k minus 1 is equals to 1, and we solve this problem for all the values of k. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem from first method. And here in the first method, you see that this k minus 1 is divided by left hand side. We need to move this into the right hand side. So when we move this into the right hand side, it will be written as k square minus 1 is equals to 1 multiplied by k minus 1. And further here in the next step, we multiply 1 on both of these two terms, and it will be written as k square minus 1 is equals to k minus 1. And in the next step, we move all the terms from right hand side to the left hand side, and it will be written as this is positive k, and when we move it into the left hand side it will becomes negative k. This is negative 1. When we move it into the left hand side it will becomes positive 1, and this whole equation is equals to 0. And now here further in the next step, you see here this is positive 1 and this is negative 1 are cancelled out by each other, and after this cancellation we get the remaining values are k square minus k, and this whole equation is equals to 0. And now you see here both of these two terms involve k, so that we need to take common k from here, and when we take common k we get the remaining values are, from here we get k minus, from here we get 1, and this whole equation is equals to 0. And now here in the next step we need to divide this equation into the two cases. The first case is we write k equals to 0, and the second case is we write k minus 1 is equals to 0. This is the first real root of the given equation, and now from here we move minus 1 to the right hand side and it will becomes here plus 1. This is the second root of the given equation. So here in this method we obtain these are the two roots of the given equation, and in the next step we need to verify that which of the root are solution and which of the roots are extraneous root. So for verification of these roots we need to copy down given question statement. Here it is k minus 1 divided by k square minus 1 divided by k minus 1 is equals to 1. So here in this side we will be verify k equals to 0, and in this side we will be verify k is equals to 1. So when we substitute k equals to 0 into the left hand side of the above equation, so it will be written as this will becomes here, when you put it here it will becomes 0 square minus 1 divided by 0 minus 1 is equals to 1 or not. This is the our claim. So you know about that 0 square becomes 0 and 0 minus 1 becomes minus 1 divided by 0 minus 1 becomes minus 1, and we see here it is equals to 1 or not. And now here further you see that this is minus 1 divided by minus 1 becomes here plus 1. So we obtain 1 equals to 1. This shows that both of the sides are equal. So if both of the sides are equal, this means that the value of k equals to 0 is satisfied our given question statement. So this is the first solution of the given equation, and now here in the same pattern we need to verify the second value of k. So when you put it here it will becomes 1 square minus 1 divided by 1 minus 1 is equals to 1 or not. This is the our claim. And now again you see here 1 square becomes 1 and 1 minus 1 becomes 0 divided by 1 minus 1 is also becomes 0 is equals to 1. And here you clearly see that it is not possible case, because if you see in the left hand side, our left hand side be the indeterminate form, or in other words we say that it is undefined form. So if our left hand side is undefined, this means that both of the sides are not equal, and if both of the sides are not equal, this concludes that the value of k equals to 1 is not satisfied our given question statement. So we finally conclude about k equals to 1 is that k k equals to 1 be the extraneous root of the given equation. Okay, so k equals to 1 be the extraneous root, because extraneous root are those roots which does not satisfy our given question statement. So here we have only one root, k equals to 0, which is satisfied our given question statement. So we call that k equals to 0 be the only one solution of the given equation, which we get here from first method. And now here again we need to solve this problem from second method, so that in second method we need to copy down given question statement here, so that our given question statement is k square minus 1 divided by k minus 1 is equals to 1. This is our given question statement. And here we use another technique to find the solution set of this problem. So here for this we here we use the nice algebraic formula to find the roots of this equation. And here we use this formula: if we have a square minus b square is equals to a minus b times of a plus b. According to this algebraic formula, we write this numerator term as, here you have k square minus 1, and we write this one as 1 square, because 1 square is equals to 1. And after applying this formula on here, it will be written as k minus 1 times of k plus 1 divided by k minus 1 is equals to 1 or not. Sorry, here we need to find the value of k. Okay, so now you see here this k minus 1 and this k minus 1 are cancelled out by each other, and here we obtain k plus 1 is equals to 1. So here you clearly see that when we move plus 1 to the right hand side, it will becomes here k equals to 1 minus 1, and this implies that we get the value of k is equals to 0. So here you see that in the second method we get only one value of k, that is 0, and in the first method we already verified that this value of k is satisfied our given question statement. So we finally conclude about that k equals to 0 be the only one solution of the given equation. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.